Have the equation x equal 3. You guys, that's easy, right? You know what the solution. How many solutions is x equal 3? Well, it's just the point 3, right? So if you were to put this on a number line, my graphing this, it would be the point 3. Okay. Now inequalities are different. How many solutions do I have to x is less than 3? Two solutions. How many numbers, or actually, yeah, how many numbers will work in this inequality statement? Will make it true. What's it? Infinitely many, right? Because doesn't doesn't two work? Two works, right? How about one? How about zero? How about -1? How about -2,360,000? So this goes out to infinity. And in the old days, we used to put brackets here, right? Yeah, like 70s and 80s. Okay. So, so I was trying to make a peace circle yesterday, the past couple of days in my office desk, playing 60s love music. Nobody appreciated that because, back in the day, everybody got along. I went through like during the pandemic for school. I went through like a big phase of like the 60s and 70s, like the war music and stuff like that. It was peace, love, and happiness. Yeah, people get got soft, so. But nobody appreciated that. I appreciated it. Somebody invented a time machine. I know one of you kids is smart enough to do that. I would say I even put Kumbaya on the stereo. I don't know who you were sitting with. I mean, that sounds lovely. Oh, it was beautiful. I was sitting there, my hands up, I was inviting people to join my circle, and nobody did. Mr. Osborne was just like, "Oh, you're playing that music again." I have a picture. I have a picture of Mr. Osborne. Yeah, I see Mr. Osborne. Yeah. All right. Anyway, back to that. So the olden days, to represent infinitely many numbers, we used to use these are called set brackets or curly brackets, whatever you want to call them. I could never make them, but anyway, to denote that it goes on forever, we used to put dots there. Okay. And then we would include a couple of numbers that work for this inequality statement. And then we would go put another dot all the way up to the number. And actually, we didn't know if that would include the 3 or not. So a little bit later than I think it was the 80s, they put a line here, and that meant such as x does not equal 3 to denote that it doesn't include 3. So it was kind of a pain in the butt. Your math, modern day math, modern day math uses what's called interval notation. Okay? You guys got some really cool notation now. Instead of doing this for every single problem, oh, by the way, you'll see this still brackets on like I think our CUDA software uses it for answers. I don't know if standardized testing uses it. I think there's all have notation now, interval notation. But just so you know, if you see this, it's just that they haven't gotten up to speed. Okay. Um, Interval notation. The way we would write this, well, remember this goes out to negative infinity, right? And then we stop at the 3 because that's where we stop, and it does not include the 3. So that's why they got this little chart up here. And you're probably asking, like, well, how do you know if it includes 3 or not? Well, I know it doesn't include 3 because there's no equal sign with that inequality, right? If I had the equal sign, then it would include the 3. because it does not have the equal sign with that inequality, I have to use parentheses. That means that, and back in Algebra 1, I think your teachers might even still do it today. They used to use open circles and closed circles, remember? Yeah. Do they still do that? Okay. So I have the way I graph this, the way I like to graph it is I put this number I put right in the middle, and I use one number bigger and one number smaller. Okay. So because a um, this is does not include the three, and I know I'm going to shade all of those numbers less than three, not including the three. The chart says I have to use a parenthesis. So I'm going to use the parenthesis so that it tells me it doesn't include three. If there was an equal sign there, then I would use a bracket. This is a bracket. Okay, these are brackets. Now remember, this goes out to negative infinity, right? This goes out to positive infinity. And our interval notation, instead of using this set of number notation, our interval notation is going to be, well, I start at negative infinity. It's always you start at left to right, just like you read. Okay? I start at negative infinity. Then I'm going to stop, comma, where I stop is at 3. And because I can never get to negative infinity or positive infinity, right, I can never include infinity. So I'm always going to use a parenthesis wherever I have infinity. And this is a terrible infinity sign. And the 3, I am not including the 3, so it gets a parenthesis. There's no equal sign. So that is my interval notation for this particular problem. So if it doesn't have an equal sign, it gets parentheses. No equal sign. Equal sign gets brackets. And no more brackets. You're doing interval notation. Now, do they teach interval notation in Algebra 1?
Probably.
Uh, don't remember. Okay, number two. Number two, let's see. My solution is x is greater than or equal to negative 2. So they want us to graph it. By the way, we don't have to solve anything here because x is by itself. Okay. When we get down to like number, this one, number 1, see how x is not by itself, so we have to solve for x. And we'll get to that in a sec. So I don't have to solve anything or do anything. All I have to do is graph this. Now here's my number line. Here's negative 2. And I want one bigger. Now remember, on the negative sign, the bigger the number, the smaller it is. So this is the bigger number, negative 1. And the smaller number is negative 3. Okay. So we want all of those numbers greater than negative 2. So all of those numbers greater than negative 2. By the way, some teachers teach this as putting, doing an arrow like that above. Either way, if you want to shade it or put the arrow, that's fine. I don't think they are changing that. Instead of open and closed circles, we need to use brackets or parentheses. This one does have an equal sign, so we want to include that negative 2. And I'm going to use a bracket. So when I go to do interval notation, let's see. You don't have to put these infinity signs there. I just do it teaching purposes. So the interval notation, well, where do I start? This time I start at -2, and it's got a bracket -2, comma, and it goes out to positive infinity, and infinity always gets parentheses. So there's my interval notation. Well, you're probably saying to yourself, hey, Mr. D, some of you may have picked this up. Um, can't we just shade in the direction of the inequality sign? Like this inequality sign's going to the left, so we could just shade to the left. Here, this inequality sign's going to the right. Can't we just shade to the right? Well, yeah, you can. As long as that variable is on the left hand side and it's by itself. If this variable is on the right hand side and the numbers here, you can't follow the arrow for shading. You have to think about it. Okay? So 1 through 5, you're just solving the inequality, then graphing it, and then putting the interval notation. So 1 through actually it's 1 through 4, but they're just numbered wrong. So 1 through 5, we're just gonna solve it and just kind of make sure we don't make mistakes. Kind of review a lot of stuff. One thing there's a difference between um, equations and inequalities. And here's that little thing you have to remember. When you multiply or divide both sides by a negative number, you have to reverse the inequality. Okay? Reverse or flip that inequality sign. Now, you can divide a negative number by a positive number and it won't flip it. But if you divide by or multiply by a negative number, you have to flip. And unfortunately, there's not an example here that shows both. I think I'll add it to number 2. Okay. So let's do number 1 first. Just like an equation, I like to put my dotted line there to organize things, keep it all organized. And I got to get x by itself. So I'm going to add 7 to both sides. Bless you. Bless you. So I'm going to bring down my 3 halves x is greater than, we're adding, so we don't have to worry about flipping that inequality sign. 2 plus 7 is 9. And the easiest way to get rid of a fractional coefficient is to multiply it by its reciprocal, both sides. These all cancel to 1. I get my x. And you guys are going to use your calculators to multiply 9 and 2/3. I'm going to get 6. Huh? Yeah. Well, I reduce before I multiply. It just does it automatically. 3 goes in the or not 3 goes in the 9 3 times 2 is 6. I've just done it a billion times. I just do it really quick. Okay, so that's my solution. It's called an inequality statement. Okay. X is by itself. That's my inequality statement or my solution. All of those numbers greater than 6 work in this original problem. We have to graph it. I need a number line. I like to put 6 in the middle, 1 greater, 7, 1 less, 5. Let's see. Um, I want all of those numbers greater than 6. So I'm going to shade all of those numbers greater than 6. Or as long as I have the variable isolated on the left-hand side, you can follow the sign. It does not have an equal sign, so I'm going to use a parenthesis, and it's going out to positive infinity. So my interval notation, parenthesis 6, comma, infinity, always gets a parenthesis. Questions? Okay, number 2. I'm going to normally I don't like working with negative variable terms, but because I want to make sure that I have my variables on that left hand side for shading purposes, I'm going to deal with negative variables with inequalities. Okay? So here, I want to keep the variable on the left hand side, so I'm going to subtract 5 from both sides. So that gives me negative 2x is greater than or equal to 22. Need to get rid of that negative 2 coefficient, so I'm going to divide by negative 2. Okay. Now, because I divided by negative 2, I have to flip or reverse that inequality sign. And 22 divided by negative 2 is negative 11. So that's my inequality statement or solution. X is less than or equal to negative 11. If I were to graph it, there's negative 11. I want one bigger, negative 10. One smaller, negative 12. See, I'm going to shade all those numbers less than negative 11 or follow the arrow. And let's say it has an equal sign, so I need a bracket. It's going to negative infinity. So, interval notation, negative infinity, which always gets a parenthesis, comma, goes to negative 11. And here I have a bracket. Now, let me see if I can do one in my head here that'll, I want to show you something. Let's see, what if I have 35 plus 2x is greater than or equal to 27? Let's do minus. Okay, so this is what I was talking about that sometimes tricks students up. Okay, to solve this, I would subtract 35, and I get negative 2x. You know what? I'm going to change that back to a positive. Positive 2x is greater than or equal to negative 8. Divide by 2, and I get x. Over here, I get negative 8 divided by 2 is negative 4. I get a lot of students that will switch this inequality sign. Do I need to switch that inequality sign? Why? Am I not dividing a negative number? No. I'm dividing by a positive number. That's okay if I divide a negative number by a positive number. You don't have to flip that sign. Okay? Only when you divide by a negative number, then you flip that sign. Do you see the difference here? Okay, that's negative 2 and that's positive 2. Negative 2, flip the sign. Positive 2, even though you have a negative number, keep the sign. It's a really, really common mistake for students. Okay? I'm just going to do number 5 down here, and then we'll be done. All right, number 5, I have a number in front of parentheses, so I'm going to have to distribute. I'm going to go ahead and put my dotted line there to keep things organized. I want to keep my x's on the left-hand side because it's going to be easier to shade. So I have 5 minus 5x is greater than or equal to 4 times 3 is 12. 4 times x, 4x, so minus 4x. Now here, again, I want to keep my x's on this side. So I'm going to add 4x to both sides. So here I'm going to add 4 to x. Undo the minus. So I get 5 minus, well, minus 5x plus 4x is a minus 1x, right? I'm going to put a 1 there to help you see things. I'm adding, so just keep the inequality sign the same. 12. Then I'm going to subtract the 5. So these 5's cancel out. I have to bring down my minus 1x. I'm subtracting, so again, we don't change the sign. 12 minus 5, 7. I have to get rid of this minus sign, so I need to divide both sides by negative 1. And because I divided by a negative number, I have to flip that sign. 7 divided by negative 1 is negative 7. Graph it. Here's my negative 7. 1 greater is negative 6. 1 less is negative 8. I want all those numbers less than or equal to negative 7. Just follow that inequality sign because it's isolated on the left-hand side. It has an equal sign, so it needs a bracket. And I'm going to put a negative infinity over here so that it helps me write the interval notation. So negative infinity always gets a parenthesis. I'm going to stop at negative 7, and it has a bracket.